Hey everybody, welcome to another math video. So for this video, I'll be going over this thing we call factorials. Alright, so this is what we'll be doing. Pretty simple, straightforward. Okay, so it's important to make the distinction between subjects here. So in English, you've seen an exclamation point, and that's what we use as the notation for factorials. So in English, you've seen exclamation points used to demonstrate feelings of excitement or disbelief. In math, we use it as kind of like a shorthand notation to mean that we're doing multiplication, but to each preceding value from the value you're starting at all the way down to 1. I know that sounds confusing in so many words, so let's just forge on ahead to the example so you can see what I mean. Okay, so here's our first example. Evaluate 4 factorial. Okay, so let's write 4 factorial, not 4. Okay, 4 factorial. So 4 factorial means this. We're going to start at 4 and we're going to multiply it to each preceding value, that is every value that's 1 less than it is until we get down to 1. So 4 factorial translates to 4 times 3 times 2 times 1. And if you multiply all that out, you get 24. So it's not as confusing as you think it is once you start seeing the examples. So let's try one more. So this one here, evaluate 10 factorial. So as you can imagine, it's going to be set up the same way as 4 factorial. Right, so it's starting at 10. That number that you're given, multiply to each descending number until you get down to 1. And once you finish setting that up, all you do is multiply it out, and you should get 3,628,800 as your answer. So like I said, pretty simple, pretty straightforward. So there's this special factorial that I do want to mention. 0 factorial is equal to 1. And you might be wondering, well, how does that work out? Okay, so let's start with this. So we know that n factorial is equal to the starting number n times n minus 1 factorial. Right, so each number less than n, 1 less than n, until you get down to 1. So we can actually rewrite this and divide both sides by n. So I get n minus 1 factorial is equal to n factorial over n. Now, this might seem weird, you don't normally see this, but I'm going to add 1 to each thing. Oopsie. There we go. I'm going to add 1 to each thing, so I get n factorial is equal to n plus 1 factorial over n plus 1. Now I can put in any random number in for n, but keep in mind, if you use any number, it has to be the same one that goes in for each n. Okay, so let's say I start with 3. So if I put 3 in for n, I get this. And if I simplify the right side of the equation, I get this, which holds true, right? Because 4 factorial divided by 4 cancels out the 4's, and you get 3 times 2 times 1, which is 3 factorial. Alright, now starting with this again, let's say n was 0, so I substitute in 0 for n, I get this, right? So simplify the right side of the equation, I get 1 factorial over 1, which would simplify to 1. Oops, sorry, just simplify to 1. So that's kind of like the proof showing that 0 factorial is equal to 1. So you don't have to remember this, but it's just easier to remember 0 factorial is 1. But I thought I'd show you guys that just so we can kind of see where it came from. Alright, so summing up, that's basically everything that we did. We noted that the factorial is an exclamation point, and in math it starts at the value that you're given, and you multiply it to each preceding number, or each smaller number, until you get down to 1. and then you just evaluate that. You just multiply it all out. Alright guys, well that's it for this video. Thanks for tuning in, and I hope it wasn't too confusing. And stay tuned for my next video. Alright.